We are all set. Okay. So, have you done arithmetic progressions in school yet?
No, sir. We've only done coordinate geometry.
Okay. So, let's understand what we mean by progression first. What is progression?
Um, Something that is succeeding in a C.
Yeah. Progression means either it goes up or it goes
Hmm.
down, right? So, like
Yes.
1, 2, 3, 4, 5, 6, this is all, going up. And if I write
Hmm.
slope -1, -2, this is going down, right? So,
Yes, sir.
and if I start from the opposite, like 10, 9, 8, this is also going down, right? So,
Yes.
this is the meaning of progression. So, progression comes from progress. That means to go in one direction, right? So, which can be either
Yes.
positive or negative. Now,
Okay, sir.
what do we mean by arithmetic? What is
Arithmetic is formula based mathematics.
no? In simple terms, by layman's term, arithmetic is 1, 2, 3, 4,
Yes.
right? That's what a layman understands by arithmetic. And
Hmm.
algebra means
Yes, sir.
x, y, z. That's what people understand by arithmetic and algebra, right? So yes, that is the meaning of that is the meaning of arithmetic progression, right? Which means that it the numbers will go in a sequence such that they are uh, progressing with a common difference. So like 1, 2, 3, 4. If I take the
Okay.
difference, this is 1, this
Hmm.
is 1, this is 1. So it is all the same. So it is
Hmm.
all increasing by 1.
Yes.
So I'm just adding 1, 1
One.
plus 1, 1
Hmm.
plus 1 plus 1, like that, right? So this
Yes,
is the
sir.
simple meaning of arithmetic progression, right? Now,
Yes.
in general, what happens? We have a starting number. Let's say I have 1. Now I can add anything to it. I can add 1, 2, 3, 4, anything, right? So if I add 1, then it becomes 2. If I
Yes.
add 2, it becomes 3. If I add 3, it becomes 4. So I can have 1, 2, 3, 4, or I can have 1, 3, 5, 7, or I can have 1, 4, 7, 10, like this, right?
Yes, sir.
So basically, this means that we are having a series where we have a first term, let that be a, and then I am adding a constant number to it, a plus d, then a plus d plus
Hmm.
d, then a plus d plus d plus d, like that, right?
Yes.
I'm just adding d to every previous term, right? Which
Yes.
means this becomes a plus d, this becomes a plus 2d, this becomes a plus 3d, and so on, right?
Yes, sir. Hmm.
So we can see that we have two things. We have a first term, which we need to know, and we need to know the common difference. Then we can find out every term.
Yes, sir.
So how do we do that? So the first term is denoted by T1. T1 means first term, right? That is A.
Yes, sir.
T2
Hmm.
is A plus D. This is a common difference.
Yes,
T3
sir.
is A plus
A
2D.
plus 2D.
T4 is A plus 3D. So
Hmm.
if I take the nth term, this would be A plus.
ND.
Look at the sequence. When this is 2, this is 1. When
Hmm.
this is 3, this is 2. When this
Hmm.
is 4, this is 3. So when this is n, this would be,
N minus 1D.
right? Why n
Hmm.
minus 1? Because the first term is A. And to that, I am
Yes.
adding d n minus 1 times to get
Hmm.
n, tn, right? So
Yes, sir.
this is the first
Hmm.
important term that we need to understand when we talk about an arithmetic progression, which is the nth term
Yes, sir.
in general. So,
Okay.
the nth term of an AP, nth term of an arithmetic progression will be Tn, which can be written as A plus n minus 1 into D, where A is the first term, n
Yes, sir.
is the total number of terms,
Hmm.
and D is the common difference. That means that the number
Yes,
that I'm
sir.
adding to each term. So
Hmm.
this is how we can define the nth term. So
Yes, sir.
if I want to find out the sum of the first n terms, sum of n terms, how will I do it? So I will just do an arithmetic addition, right? Simple
Hmm.
addition. T1 is A, T2 is A plus D, T3 is A plus 2D, T4 is A plus 3D, and up to n, right? A plus
Yes, sir.
n minus 1 into D, right? Correct?
Yes, sir. Yes, sir.
So my sum of the first n terms, sum of n terms will be equal to how many A do I get? 1, 2, 3, 4, up to?
So I can't hear you.
No, I'm saying how many A's do I get?
Hello.
Can you hear me?
Yes, now I can hear you.
Okay. So I'm trying to find the sum of the n terms. So I'm just adding all the terms, right?
Okay.
And the
Hmm.
terms have each term has two parts. One is the constant A, and the other one is some
Yes.
multiple of D, right?
Yes, sir.
So how many A's do I get?
N.
N. So there are n A's, and
Yes.
I can take D common, and then I will get 1, 2, 3, 4 up to n minus 1, right?
Yes, sir.
N minus 1, right? So we have to know
Yes, sir.
what is the value of this. Then we can find the sum of the n terms. Correct?
Yes.
Okay. So let us try and find the value of this one. So what we are trying to find is the sum of the first n natural numbers, 1 plus 2 plus 3 plus 4 plus n, right?
Yes.
So how do we get this?
The sum of the um number of terms.
Yes, but what is the value? I have to find the value of this sum in terms of n.
Hmm.
Okay. So the way to do this
Yes.
is do this is very simple. We know n square minus n minus 1 whole square is what? This is n square minus of
Yes.
n square minus 2n plus 1, right? So
Yes.
which is
Hmm.
equal to n square, and n square minus n square will cancel out. So we'll get 2n
Hmm.
minus 1. Correct?
Yes, sir.
So we can write I'll put values of n now. So 1 square minus 0 square is equal to 2 into 1 minus 1, which is 1, right?
Yes, sir.
N equal to 1. I'm putting n equal to 1 in this equation,
Okay.
right? I'm putting n equal to 2 in this equation. So 2 square minus 1 square is equal to 2 into 2 minus 1, which is 3.
3.
N equal to 3. I will get 3 square minus 2 square is equal to
5.
5, right? And
Hmm.
up to n square minus n minus 1 square is equal to 2n minus 1, which I know, right?
Yes.
So now if I
Yes,
add all
sir.
of this, what will happen? 1 square and minus 1 square will cancel out,
Yes,
correct?
sir.
2 square and minus 2 square will cancel out. 3 square and minus 3 square will cancel out. Minus n minus 1 square and n
I can't
minus.
hear you.
Can you hear me now? Hello?
Yes, I can hear you now.
Okay, so what I'm saying is if I add all the terms, you see that the first term and the second term of the consecutive terms will cancel out. So 1 square and minus 1 square, 2 square
Yes.
minus 2 square, 3 square
Yes.
minus 3 square. Similarly, n minus 1 minus of n minus 1 square will cancel with the previous one, right? So we will be left with n square minus 0 square. So 0 square is 0, right? So if I add all these terms, I will get n square is
Yes.
equal to, this I can write as 2 into 1 minus 1. This I can write as 2 into 2 minus 1. This I can write as 2 into 3 minus 1, right? Correct? Hello? Hello?
Yeah.
Can you hear me?
Yes, I can hear you.
Okay. So therefore
Yes, sir.
I can write this as taking 2 common, 1 plus 2 plus 3 plus 4 up to n minus.
Yes, sir.
How many ones do I get?
N.
N, right? So therefore I can
Yes, sir.
write this as n square is equal to twice sum of n terms, which I was trying to find out. Sum of n terms of the first n natural numbers, right? This is the sum of the n terms, right?
Yes.
2 sum of n
Yes, sir.
minus n, correct?
Hmm.
So therefore 2 sum of
Yes,
n
sir.
is equal to n square plus n. I take the n this side minus n this side.
Yes.
That is equal to n into n plus 1, right?
Yeah.
So Sn will be n into n plus 1 divided by 2. So now I have got the sum of the first 10 terms. Did you understand this? Hello?
Yes, sir.
Did you
Will we
get?
take maybe two also to both lines? Okay.
Huh? Sorry?
I got you. The connection wasn't good, so I couldn't see the part you wrote.
Okay, let me repeat this. No issues.
Hmm.
So what did I do? I got this identity that n square minus n minus 1 whole square is equal to 2n minus 1, right?
Yes, sir.
So from this, I can put the values of n equal to 1. If I put n equal to 1, then this becomes 1 square minus 0 square is equal to 2 into 1 minus 1,
Yes, sir.
n equal to 2. This becomes 2 square minus 1 square is equal to 2 into 2 minus 1,
Yes.
n equal to 3. 3 square minus 2 square is 2 into 3 minus 1, and I
Yes, sir.
continue this till n equal to n. So then n square minus n minus 1 whole square, that is equal to 2n minus 1. We already saw that. So 2n
Hmm.
minus 1, right?
Yes, sir.
So I will just add up all these terms. Now when I add up all these terms, what happens is 1 square cancels out with minus 1 square, 2
Yes,
square
sir.
cancels out with minus 2 square, 3 square will cancel with minus 3 square here. Similarly,
Yes.
n minus 1 square will cancel with n minus 1 square here, right?
Yes,
So we
sir.
will be left with n square minus 0 square. 0 square is 0. So therefore,
Yes.
n square is equal to twice of 1, 2, 3, 4 up to n,
Yes.
minus I have 1 so many times. How many times
Yes.
do I have 1?
N.
N. So what is this? This is the total sum of the n terms that I'm trying to find out here.
Yes.
This is Sn. So
Hmm.
n square is equal to 2Sn minus n.
Yes, sir.
So therefore 2Sn is equal to n square plus n.
Yes,
I
sir.
take this here. That is equal to n into n plus 1. So
Yes, sir.
therefore Sn is equal to n into n plus 1 divided by 2.
Upon 2. Yes.
So this is the sum of the first n natural numbers which I was trying to find out. So this is
Okay,
n
sir.
into n plus 1 over 2, right?
Okay.
So in
Hmm.
order to find the sum of any arithmetic progression, this is the thing that we need to know. We have to use this
Okay, sir.
particular thing. So now
Hmm.
let us say I have a arithmetic progression where T1 is equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, right? T4
Yes,
is
sir.
equal to A plus 3D, and so on up to Tn. Tn is equal to
Yes, sir.
A plus n minus 1 D.
Minus 1D.
And I add up all of this. So sum of n terms here will be equal to, how many A's do we have? 1, 2, 3, 4,
N.
n. N A
Yes.
plus D I can take common. It is common for all terms, into
Yes, sir.
1 plus 2 plus 3 plus dot 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 up to n minus 1, right?
Yes, sir.
So therefore now we can write the sum of n terms of the series.
So the last line I didn't get. What did you say?
So now we have got the sum of n terms of this series as
Yes.
n into a plus d into 1 plus 2 plus
Hmm.
3 up to n minus 1,
Yes, sir.
right? So we can write Sn is equal to Na plus d into 1 plus 2 plus 3 up to n minus 1, which is nothing
Yes,
but,
sir.
this is nothing but the sum of first n minus 1 natural numbers,
Okay, sir.
correct?
Yes,
And
sir.
we know that the sum of the n natural numbers is n into n plus 1 by 2, right?
Yes,
So
sir.
what would be sum of n minus 1 natural numbers?
We'll put minus 1 to the n into n plus 1 by 2 equation.
So in place of n, we will put n minus 1. So
Yes, sir.
on the right hand side also, In place of n, we will put n minus 1. In place of n, we will
Okay.
put n minus 1. So what will that be?
N minus 1 into n minus 1
Plus 1.
plus 1
Yeah. So in place
by.
of n, I will put n minus 1. So this
Yes,
becomes
sir.
n minus 1 plus 1, right?
Yes, sir.
Divide by 2. So that is equal to n minus 1 into n by 2. Correct?
Yes, sir.
Right? So,
Yes, sir.
so this would be equal to na plus b into, in place of this, I will write n into n
Man.
minus 1 over 2.
Yes,
Correct?
sir.
So then I will simplify this. I can take n common from both these terms, right? So n
Yes, sir.
into a plus n minus 1 into d by 2,
Yes, sir.
and I will take uh, I want to take this 2 out also. So n by 2 into 2a plus n minus 1 into d.
Yes.
This is the sum of n terms of any arithmetic progression.
Okay, sir.
Okay. Now,
Yes, sir.
uh, see, the sum of n terms of the natural numbers is n into n plus 1 by 2. That means if I want to find the sum of the first four terms, that will be 4 into 5 by 2.
Yes.
Sum of first 10 terms will be 10 into 11 by 2.
Yes, sir.
So remember this, if you are asked to find the sum of any um, number of uh, natural numbers, it will be the natural number itself into the next number, divide by 2.
Yes, sir.
Okay.
Yes, sir.
And this
Hmm.
can also be written as, in case of any arithmetic progression, this can be further uh, rearranged as a plus n minus 1 into d. Correct?
Yes, sir.
Can I?
Why have you put the n inside? Why have you put the other a? Acha, like for 2a, okay.
Yeah, I had 2a, so I split it into 2a's,
Yes, yes.
right? So this I can write
Yes,
as
sir.
n by 2. And why did I do this? I'll show you. I can write this as a plus n minus 1 into d is what? This is the nth term.
Yes.
This is equal to n by 2. A is the first term. So T1 plus Tn. And why did I do this?
So can you repeat the last line? Can
So,
you repeat the last line?
so T1 is A. T1 is
Yes.
A. So in place of A, I'm
Hmm.
writing T1.
Yes.
And in place of A plus n minus 1 into D, I'm writing Tn.
Yes, sir.
So I can write this as n by 2 into T1 plus Tn.
Yes, sir.
Okay. Let us now summarize all this and let me explain why did I do all this.
Okay, sir.
So first we saw that the sum of the first n natural numbers is equal to n into n plus 1 by 2. Then we saw
Yes,
that the
sir.
sum of the first n terms of any arithmetic progression is n by 2 into 2a plus n minus 1 into d. And this can also be written as n by 2 into t1 plus Tn. Now tell me, why did I do all of this? Why did I do these two things? This one and this one.
It is shortening the equation and making it simpler.
Not really. That is just a side effect, I would say. The real reason is, see, I can give you the series in two ways. I can tell you that I have a arithmetic progression where the first term is 6 and the common difference T1 is 6 and the common difference is
Hmm.
3, right? That means the series would be
Yes, sir.
6, 9, 12 like this, right? So tell me the sum of the first 10 terms. So sum of 10 terms will be equal to 10 by 2 number of terms. 10 is n, so 10 by 2
Yes.
into twice the first term, which is 6, plus
Yes.
n minus 1 into d. So n is 10, so 9 into 3,
Yes, sir.
whatever the value is. Okay, I'm not calculating it. So this is one way of calculating it. But
Okay.
if I don't give you the common difference, I tell you that the first term is 6 and the last term is 32.
Okay.
I don't tell you the common difference, and I tell you that um, there are 14 terms,
Okay.
right? There are 14 terms. First term is 6, last term is 32. So
Okay.
then it is easier to use this formula.
Yes, sir.
Then I can straight away say that the sum would be, sum of the first 14 terms would be 14 by 2 into first term is
Yes.
6, last term is 32, whatever that value is, right?
Yes, sir.
However, you can find out the value of d also, because this is a plus n minus 1 into d, where a is
Yes.
6, n is 14 minus 1 into d. This is 32.
Yes.
So 32 is equal to 6 plus 13d. So therefore d is 32 minus 6, 26 over 13, which is 2.
Yes.
So you can do this, but you see, if you try to do this, you will first have to calculate d, then put this
Yes,
back
sir.
in this equation and calculate again,
Hmm.
right? But
Yes,
if
sir.
you do it straight away using this, you will get the answer straight away without having to do all of this.
Okay, sir.
Clear?
Yes, sir.
So whenever you are asked to find the sum of n terms in a arithmetic progression, what would you look for? What are the things that you need? You need the number of
Number
terms,
of terms.
which is n. You need the first
Yes.
term, which is a, and
Hmm.
you need the either the common difference, either
Hmm.
common difference
Yes, sir. Or the last term.
or the
TN.
last term, right?
Yes, sir.
Now there can be a third possibility. Suppose I tell you that I have a series like 3, starting with 3, and the um, fifth term fifth term
Yes.
is equal to 19, right? Find the sum of the first 10 terms. So I have not given you the
Okay.
last term. I have not told you the common difference.
Yes.
This can also be a possibility,
Okay.
right?
Yes, sir.
So how do we deal with this kind of problems? So one classical way is, you know, the fifth term, 19. You know the first term.
Yes.
So you can put that formula, a plus n minus 1 into d
Yes.
is equal to 19. right? Where A is 3, you don't know um, n and D, right?
Yes.
So you can only find out the value of n minus 1 into D is equal to 19 minus 3, which is 16,
Yes.
right? Oh, sorry, I told you the fifth term. So n is 5 here. Sorry.
Oh, yes.
So this is, in this case, you can find out D equal to 4. But if I don't tell you
Hmm.
this term, I just tell you that there is a term which is 19, okay?
Okay.
And it is the nth term of the sequence. Nth term
Okay.
is 19,
Yes.
right? So find out the sum of the first 10 terms.
Yes, sir.
So then I cannot find out D because I am not told n.
Yes, sir.
But I can find out n minus 1 into D,
Yes.
correct?
Yes, sir.
So sum of first 10 terms will be 10 by 2 into twice A, which is twice of 3, right?
Yes,
3
sir.
is the first term, plus
Hmm.
n minus 1 into D.
Yes.
Understood?
Yes, sir.
Clear?
Yes, sir.
So this is a very tricky way of giving you a problem on AP. This is the most trickiest way.
Okay.
Okay. If you are told that the first term is this and the fifth term is this, you can straight away find out the value of D, right? Or if
Yes.
you are told the first and the last term and the number of terms, you can straight away find the value of sum of the n terms. But if you are
Yes, sir.
not told which term is
Hmm.
19, you were just told that there is some term which is the nth term,
Hmm.
that is 19,
Yes.
right? So in that case, you cannot find the value of n or
D.
D.
Yes.
Clear?
Yes, sir.
So in that case, you have to just find out the value of n minus 1 into D and replace it in the given equation.
Yes.
Okay. So these are the various ways that we can find the sum of an arithmetic
That.
series,
Hmm.
right? Now, uh, let's say I have an arithmetic series where the first term is less than 0. Okay,
Yes, sir.
the nth term is equal to 0, right?
Okay.
Find the sum of 2n minus 1 terms.
Yes, sir.
So how will we do it? See, we don't know the last term, right? So
Yes.
we
So
can
we use two.
we cannot use this.
Yes.
We have to use
So we use n by 2, 2a
s to.
plus n minus 1 into d.
Yes, correct. So in place of n, I will write 2n minus 1.
2n minus 1.
Wherever there is
Yes,
n,
sir.
I will write 2n minus 1. So tell me what this will be.
2n minus 1 upon 2 into 2a plus 2n minus 1 whole multiplied by d.
No, I am putting 2n minus 1 in place of n.
Okay. -1 again.
Yes, be careful with this one. People make a lot of mistakes here.
Okay, sir.
Into d.
Whole by D. Yes.
Okay, then
To 0.
sorry, this will be 2n minus 1 by 2 into
Yes.
2a plus d into 2n minus
Hmm.
2,
Yes.
right? So this can be written
Yes, sir.
as 2n minus 1 by 2 into 2a plus 2d into n minus 1.
Yes, sir.
So this would be 2n minus 1 by 2 into, I take the 2 common from both terms,
Yes.
2 into a plus n minus 1 into d.
Yes, sir.
What is a plus n minus 1 into d?
The nth term.
This is Tn. What is Tn given as?
Yes. 0.
So this whole thing would be 0.
0. Yes, sir.
So the answer would be 0. Got it?
Yes, sir.
See, these are the tricky questions that might come where you don't know the last term, you just know the first term, you don't know the common difference, right? So
Yes, sir.
in that case, you have to use, you know, uh, you have to use either the nth term, which will be given,
Yes, sir.
or like I showed earlier, if you are just told that your T1 is 3 and Tn is 19, where you're not given the value of n, so you can calculate n minus 1 into d, which is 19 minus 3,
But yes, sir.
right? Clear?
Yes, sir.
Okay. Now let us look at some more important ones.
Okay.
So now I want to find the value of 1 square plus 2 square plus 3 square plus 4 square up to n square. How will I do this?
Yes, sir. You will use the first equation, which is Sn is equal to n upon 2
No, no,
whole to a.
I can't do that because here the what is the common difference? See here the first term is 1,
It's 1.
second is 4, right?
Yes.
Third is 9, fourth is 16, like this.
Yes.
Now if I take
Hmm.
the difference of these two, this is 3, this is 5, this is 7, and so on. So this one is an arithmetic progression, not this one.
Okay.
So I cannot use this formula here.
Okay.
Okay.
Yes, sir.
So what can I do? See, when I calculated the sum of the first n terms of the
Yes.
some of the first n natural numbers, I started with n
Yes.
square minus n minus 1 whole square is equal to 2n minus 1.
Hmm.
This is what I started with. Right? Now,
Yes,
if
sir.
I want to find the square, sum of the squares, what should I start with?
Mm,
when I was trying to find this, okay,
Hmm.
I started with n square. When I'm
Hmm.
trying to find n square, what should I start with?
N raised to the power 4.
No, n to the power 3. Just one power high. So I will do the
Okay.
same thing, n cube minus n minus 1 whole cube, right?
Okay.
So
Yes, sir.
this is what? N cube minus n cube minus
Hmm.
3n square plus 3n plus minus 1, right?
Yes, sir.
Correct?
Yes, sir.
That's the formula of a plus b whole cube.
Yes, sir.
So n cube and n cube will cancel. So I will get 3n square minus 3n plus 1,
Yes, sir.
n cube minus n minus 1 whole cube, right? So then I will
Yes,
do the
sir.
same thing. I will write 1 cube minus 0 cube is equal to 3 into 1 square in minus 3 into 1 plus 1, right? 2 cube
Yes, sir.
minus 1 cube is equal to 3 into 2 square minus 3 into 2 plus 1. 3 cube
Yes.
minus 2 cube will be 3 into 3 square minus 3 into 3 plus 1, right? All the way up to n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1, right?
Yes, sir.
Next, what should we do?
First, we add the
We will simply add everything.
hmm.
So this will go out, this will go out, this will go out, this will go out, and we will be left with n cube.
N cube minus 0 cube.
0 cube is 0. So n cube
Yes.
is equal to
Hmm.
3 into 1 square plus 2 square plus 3 square up to n square. This is what I'm trying to find out, right?
Yes, sir.
Minus 3 into 1 plus 2 plus 3 up to n. What is that?
Plus n
1 plus 2
1 n.
plus 3 plus up to n plus n. Yes,
Yes.
plus n. So I can
Yes.
write this as n cube is equal to 3 into the sum that I'm trying to find out, sum of squares, right?
Yes, sir.
Minus 3 into sum of first n natural numbers, right?
Yes, sir.
Plus n, right? So
Hmm.
this is equal to 3 square Sn square. I mean, sum of the squares of n terms minus 3.
Yes.
What will be this? Sum of the first,
N n into n plus 1 upon 2.
right? N into n plus 1 over 2 plus n, right?
Yes, sir.
So therefore, I can write 3 Sn square is equal to n cube plus 3n into n plus 1 over 2 minus n,
Yes, sir.
right? So,
Yes.
so therefore that will become n cube minus n plus 3 into n plus 1 by 2. 1 second. 3 into n plus 1 by 2.
Hmm.
So this I can write as n into n square minus 1, right?
Yes, sir.
3 by 2 into n plus 1.
Yes.
What is n square minus 1?
Um,
What is a square minus b square?
n plus 1 n minus 1. We write.
N minus 1 plus 3 by 2 n into n plus 1. Now you see
Hmm.
that in both terms n into n plus 1 is common.
Yes, sir.
So this can be written as n into n plus 1 into n minus 1 plus 3 by 2.
Yes, sir.
Correct?
Yes, sir.
So this is n into n plus 1 into 2n minus 2 plus 3 over 2,
Yes, sir.
which is n into n plus 1 into 2n plus 1 by 2,
Yes, sir.
and this is equal to 3sn square.
Hmm.
So Sn would be n into n plus 1 into 2n plus 1 by 6.
Yes, sir.
Got it?
Yes, sir.
So this is the sum of the first sum of the squares of the first n natural numbers,
Yes, sir.
right?
Yes, sir.
Okay. Now let us do some problems quickly. You have a hard stop at 12, right?
Yes, sir.
Okay. We'll just take a couple of problems and then we'll continue next time. So,
Okay, sir.
so let us say I have um, okay. So there is a pole, okay,
Hmm.
and there are some pebbles that are there around the pole, right?
Okay.
Now a guy comes and picks up one pebble at a time and goes and puts it and comes back.
Okay.
Okay. So
Hmm.
he goes 10 meters, puts it, comes back. Again, he picks up one pebble, goes again 20 meters, puts it, comes back. Okay. Like that.
Yes.
Okay.
Hmm.
He goes on. Okay.
So he increases his distance by 10 every time
Correct.
while he's going to. Okay.
And the total distance is 200 meters.
Okay.
Right.
Yes,
Total
sir.
distance is 200 meters.
Meters.
Right.
Yes, sir.
So, what is the total distance that he will travel?
200 meters.
So, see what is happening. He's picking up one, the first one. He goes
Yes.
10 meters, puts it,
Okay, so.
comes
Okay,
back.
okay, I got your question.
Okay,
Hmm, hmm.
so for the first one he travels 20 meters. For the second one
Yes.
he goes 20 meters and comes back 20 meters.
40.
Okay, so for the first one he travels 20, for the second one he travels 40, for the third one he'll travel 60, and so on.
Okay.
right?
Yes, sir.
So for the last one, how much he has to travel?
400.
400. Very good. He has to go and
Hmm.
come back. That's it. So
Yes.
go and come back. So 200
Yes,
plus
sir.
200, 400. So
Yes,
this is
sir.
what? This is the total distance he will travel.
Hmm.
Plus, all plus, right?
Yes, sir.
So how will you find this out?
So we can take n upon 2
Hmm.
into t1 plus tn.
Yes, but do you know n?
N is 20 because we'll divide 200 by 10, so it'll become 20, 20 times.
Okay. So then what would be the distance?
It will become 20 upon 2
Hmm.
into 20 plus 400.
Correct. So this is 10 into 420, which is 420,
4200.
right?
Yes,
So
sir.
this is you know a practical problem on arithmetic progression,
Yes, sir.
right?
Hmm.
Okay. Let us look at one more case. Let us say I have an equation 3x plus 4y is equal to 50. Find the sum of all possible values of x. Remember we did this yesterday?
Yes, sir. Um, can we leave x on the left hand side and take all the values to the right hand side first and then solve
Correct.
it?
Correct. So that means
Hmm.
3x is equal to 50
50 minus
minus
4 by,
4y by 3.
then x is, yes,
So 50 by 3 means 16, which is 48 plus 2 remains, right?
yes,
2 minus 4y by 3, right?
yes, sir.
So this is equal to x. So that means
Yes,
this has to be an integer,
yes.
right? X is an integer,
Hmm.
positive integer, right?
Hmm.
So this has to be an integer. So we will straight away put the value of y to find out the value of x. So what could be the minimum value of y? That would be 1.
1.
So if it is 1, so it becomes 2 minus 4 by 3. So x is not becoming an integer. So this will not be the case. So next we put
Yes,
2. So 2 minus 8 by 3. That means minus 6 by 3, which is minus 2, right? So
yes.
then it will become
Hmm.
16 minus 2, which is 14,
Hmm.
right? So this is all we need. Why?
Yes, sir.
Because I showed you yesterday that, and you can go on with the other terms. But when you do this, remember that
Hmm.
x will increase by 4 and y sorry, x will decrease by 4 and y will increase by 3. So the next one
Yes,
would be 5, right? And this would
yes, sir.
decrease by 4, which means the next one would be 10.
Yes, sir.
Correct?
Yes, sir.
So now, what is the minimum value of x that can happen? 1, right? But will 1 fit
Yes.
in? If I put 1 here, 1 is equal to 16 plus, or let me put this in the original equation. So 3 plus
Okay.
4y is equal to 50. That means 4y is equal to 47, which will not work.
Yes.
So 1 cannot be the case, right?
Hello.
Yeah. Hello. Hello.
Hello.
Yeah. Can you hear me?
Yes, I can hear you now.
Okay. So 1 cannot be the case. So the next value would be 2.
Yes.
So if I put 2 here,
Hmm.
so 2 into 3 is 6 plus 4y is equal to 50. So y is equal to 11.
Yes. Yes, sir.
So this can be a case where x is 2 and y is 11. So that therefore x will take
Yes, sir.
values from 14 to 2, 14,
Hmm.
10 like that to 2. So the first is 14,
Hmm.
last is 2. How many terms?
14 minus 2 upon 4.
No. See, this is what I wanted to show you. Tn is equal to n
Okay.
minus 1 into d plus a, right?
Yes.
And we are trying to find out the value of n, right?
Hmm.
So therefore n minus 1 will be equal to Tn minus a by d,
Yes, sir.
nth term minus first term, last term minus first term over the common difference,
Yes,
that
sir.
is n minus 1, and n would be Tn minus T1 by d plus 1. So 14 minus 2, right?
Yes, sir.
What is the common difference?
4.
Plus 1,
Okay.
right? So which means 12 by 4, 3 plus 1, 4 terms,
Hmm.
right?
Yes, sir.
So therefore you can find the value now. So you know there are 4 terms, 4 by 2, first term is 14, last term is 2. So this would be the value.
Yes, sir.
Okay.
Yes, sir.
Okay. So we'll stop here for today, and we'll continue tomorrow.
Yes, sir.
Okay. Okay.
Yes, sir.
Okay, Prisha.
Thank you, sir.
Have a nice day. Talk to you tomorrow.
Thank you, sir. Yes,
You're
sir.
welcome.
Bye.
Bye.